got emissions which are actually less. Estimates vary, but it's around about the medium of those estimates is something like about 50% lower than coal. So you've got a strong combination of characteristics as an energy source, which mean that gas is seen by many to have a very bright future. And let me just take one moment to talk a little bit more about that issue of the availability and the supply and the abundance. I mentioned that unconventional resources are changing the game to the point now where the IEA is projecting 250 years of current production from by the combination of conventional sources and unconventional sources. And the other point to note here is how widely geographically dispersed they are through the world. There's a bit of a tendency, I think, in Australia to think about the fact that we have all these resources and no one else in the world does. That's not so. I mean, the challenge here is being able to develop those resources in a commercially viable way. Let's look at the picture in Australia. Australia has around about 320 trillion cubic feet of conventional and CSG, coal bed methane or coal seam gas resources combined. So we use about 1 TCF domestically, and currently we're exporting about 1 TCF. That's projected to, domestic and export demand is projected to double to around about 4 trillion cubic feet by 2020. So just on coal seam gas and on conventional reserves, we've got something like 80 years of known reserves and resources. But that doesn't take account of one of the issues on the chart there, which is shale gas resources, on the basis of a study which was completed in the US for world gas, shale gas resources, and it also doesn't take account of technology. Shale gas is a very, very new industry in Australia. There are some companies looking for shale gas. In fact, we've got some good deposits in the northwest of Western Australia and also South Australia, but the focus has been very much on project development in the conventional and unconventional space. Tony, you'll stop me if I go too long, right? So what's happening here locally? Well, this just gives you a picture, something which might not be obvious here in Melbourne, of what's happening in this industry. It's in a tremendous growth phase. We have 3 LNG projects today, 2 in the west with North West Shelf and Pluto, which are shown on the chart there. But we've got a further 7 which are under development, which are actually approved and are going ahead. There's 3, the coal seam gas to LNG projects in the east there, centred around Gladstone, as well as another 4, which are under development in the north and the west, one of which, for example, is Prelude, which is a new technology, a floating LNG plant. Altogether, this adds up to something like $170 billion of investment. It's a huge amount of investment, and maybe if I can just give you a little bit of a picture of that. Those projects, if you think about the Snowy Mountain scheme, in today's dollars that was worth about $8 billion. So each of these projects are worth more than the Snowy Mountain scheme. That's those 7 projects which I mentioned. And one of them, in the case of Gorgon, which is a $43 billion project, is around about 5 times the size of the Snowy Mountain scheme. So that gives you just a little bit of a picture.
Of Australian GDP.
I beg pardon?
4%. 4 billion dollars. It's 4% of Australia's GDP.
But we might come to that a little bit later on.
Put it in perspective.
We could save the questions till...
Yeah. Okay, I will give you some GDP numbers, but I'm just trying to give you a picture of what's actually happening in the industry. Okay, this one I won't go through, but as well as those ones that I talked about, which are committed investments, you have many investments which are underway, which are planned but not yet actually approved. Okay, when we talk about investment, value of definite resources projects by sector, this chart just makes the point that 74%, close to 3/4 of those are going on in that LNG sector. When it does come, however, to GDP numbers, yes, the oil and gas industry now accounts for something like 2% of GDP. When you look at these projects which are underway, and the production profiles when you pull through the capital and also the value of the output, that's set to go to about 3.5% by 2020. Now that is a big number. That's around about a third of the total primary industry component of the economy in the country. Okay, what does this mean for the economic significance when it comes to exports? Okay, very quickly, we're on the way from going from 20 million tonnes of LNG exports to around about 80 million tonnes of LNG exports, just from those projects which I mentioned, which are approved, and that would put us up there with Qatar as a major supplier. Okay, we can probably get into this a little bit more into questions and answers, and I think Michael's covered this one, so I won't really belabor the point here. The final point I'll just make here is that, you know, the seminal issue is how do we meet our demand at the same time as reducing emissions? And if the goal is to have affordable, secure, reliable, clean energy supply sources, the first thing I think we need to focus on is energy efficiency, which helps to reduce demand, fuel switching, and I don't want to make this a coal versus gas story, because I agree fundamentally with Nikki's point that we're really looking at all sources of energy here, but switching from coal to gas is one of the ways in which one of the biggest near-term opportunities we have to be able to reduce our emissions. And the third one is investing money in technology breakthroughs, carbon capture and storage, which we'll talk about, obviously more competitive renewables, and even nuclear, particularly on a global scale, are going to make their contribution towards reducing emissions and keeping energy flowing. Thank you very much.
Maybe to start initial conversation and get a couple of topics on the table. One issue that was raised and referred to by all three speakers was the role of carbon capture and storage. There'd be many who'd say this is a technology that's too expensive, unproven, and shouldn't be supported because all it's doing is prolonging the life of technologies we should be getting rid of. On the other hand, if you look at the sort of numbers that were being put up, suggestion is that if we're going to seriously reduce our emissions at the extent we have to and continue to provide secure, reliable energy, then CCS is fundamentally part of that. And yet, in the world, CCS struggles to move forward. So I guess I'm interested to see how do the three speakers reconcile the conundrum that says for the fossil fuel industry to have a future in a low emissions energy future, we need an awful lot of CCS really fast, and why isn't that happening? So I'd be interested to see, Michael, do you want to, what your thoughts are about that, and get both Nikki and David to comment as well on, well, how do you, this is a fundamental conundrum to me.
And me too.
Is that your answer?
And I'd like to add two specific things. The first is one question I asked in my own presentation was, you have an upstream industry, the people who bring the stuff out of the ground and export it and sell it domestically, and then you have the people in the fossil industry who burn it to make electricity and other energy services. And they're very different organisations that do that. So how are the people who are bringing the stuff out of the ground helping those who would ultimately implement CCS? That's my first question. And my second question is one of that's outside my area of specialisation. I'm just an engineer, and that's a financing question. I would guess banks at the moment don't like lending very big pots of money. So if I went as a consortium or as a big company and said, can I please have a big loan to build a prototype CCS plant, I think that could be a hard sell. So they're two things I'd like to discuss, if possible.
Well, I mean, everyone is completely correct. I think if I look back 10 years ago, our industry was infinitely more optimistic than it ought to have been about the technology path. In other words, the speed with which we would crack the breakthroughs. And I think that there are a couple of important things to think about in terms of the technology. Using CO2 capturing CO2 and injecting CO2 is something that, in fact, the oil and gas industry has been doing for well over 20 years as part of enhanced oil recovery. So that part of the technology is actually quite well known. The unusual thing, the tricky part, is the application of capture technologies to power stations. And there again, it's not that the technology is undoable. We have had a very successful post-combustion capture project at the Delta Power Station in New South Wales, where they captured 95% of the CO2, and my organisation, on behalf of the industry, is investing in that project. We have another project at Callide in Queensland, which is called oxy-firing, where basically you are combusting coal in oxygen as opposed to air. And because you're combusting it in oxygen, you actually you greatly concentrate the amount of CO2 in the flue gases that come out of the power station, which means that you can capture them much more cost effectively, because diffuse gases mean it's much more expensive to do. So there are these technical parts of the puzzle which the industry, through ACOLET, which is a collaboration with the CSIRO, with the CO2 CRC, with other research institutions, with power stations, most of which, of course, are government-owned, and that can always be a little bit complicated to have that kind of relationship, to your point, Michael. So there is quite a significant collaboration in this country between the producers of coal and the scientific community and the consumers of coal. But the technology, the above-ground technology, the power station technology, is clearly much more expensive than we anticipated. And the kinds of trials and demonstrations, and for all of you who are scientists in the audience or engineers would recognise that projects, you learn as much by your failures as you do through your successes. And we have been going through a series of successes and failures, and using that information to contribute to the sort of broad body of knowledge. But what we're asking to do, what we're being asked to do, to bring CCS in terms of its power station application to commercial scale in a very quick time frame, is unparalleled, I think, in our technological experience. So it would be like saying or trying to imagine whether the sewer system in Victorian England would ever have been built without public funds. So the industry, our industry, is contributing money. We're working with scientific community. But what we don't have when we apply CCS technologies to a power station is a revenue stream. So if you use carbon capture for enhanced oil recovery, for example, you have a revenue stream, and that's a very big difference. So what we're seeing around the world, and what will have to happen in Australia, is that you've actually got multiple industries that benefit from and feed into an integrated carbon capture and storage project. Example being Rotterdam, for example, where you've actually got businesses that need a huge amount of nitrogen. You've got the greenhouses that they use for the commercial flowers. They need hundreds of tonnes of CO2, so they actually need the CO2 that's being produced by the power station. They've got pipelines at the port going out to a very deep aquifer, but you've got other industrial processes that are actually building connections to this pipeline to either give their excess CO2 or to take the CO2 or other byproducts of the process. And that is where you start to get a commercial model that makes sense, but where you have huge commitment by the Rotterdam local government, by the Dutch government, where it sits inside the EU's own strategy for climate change responses, where CCS is a key part. So you've got all of those pieces. You've got commercial pieces, you've got political pieces, you've got the legislation, you've got an industrial benefit, a commercial benefit for the players. We don't have that in Australia yet, and that is our biggest challenge.
Just a quick comment from me. I mean, not much I disagree with there. I mean, I think the big issue is cost. The other one, which Nikki didn't touch on, really is the fact that the storage site has got to have the right